Passwords. In this nugget, we'll be discussing passwords, and boy, isn't this fun. We'll start off with a discussion just of what really passwords are in a Windows environment or in a Linux environment. We'll see that it really revolves around hashing and the various types of hash methods that we'll be taking a look at here, as well as how to crack those hashes. You don't really crack the hashes directly. You simply run passwords through a computational algorithm that then gives you a result. We'll take a look at how that process works. We also see that it's important, if you want to look at using good security methods for your organization, to choose good passwords. And you need to have good password policy. We'll look at some of the requirements that could be involved there. And then you also need to be realistic when it comes to password cracking. Sometimes it just takes too long. Sometimes there are better solutions for breaching security than password cracking, although it's a lot of fun to crack passwords. And then we'll take a look at quite a few different things we can use to crack passwords, a few different utilities at least. And I'm showing you the best ones that I've seen. There's dozens of them out there. I'll show you 2 or 3 of them that are really, really good. One of my favorite TV shows this year is a TV show called What About Earl? It's a comedy about a man named Earl who tries to make things right for all the things that he's done wrong in his life in the past. And his brother Randy accompanies him on most of his adventures. Well, at one point, and I don't remember all the circumstances, but at one point they'd stolen a laptop and they were trying to break into it by password guessing. And Earl would think of a password or two. He was unsuccessful. Randy would think of a password or two, but they were real simple passwords like, car, dog, things like that. And Earl would say, you can't think of those kinds of passwords. Randy, you have to think of passwords that other people would think of, not passwords that you would think of. So Randy tries another couple of tries, and he gives up in frustration, and he says, dang it, I can only think of passwords that I can think of. Well, what a conundrum. And isn't that the conundrum that all of us as hackers face as well? If everybody thought like we thought, well, we could guess everybody's passwords pretty easily now, couldn't we? But in our situation, we very often have to crack passwords. But before we get into cracking passwords, let's take a look, first of all, at some fundamental groundwork for what passwords really are and where we can access them. All right, passwords really, when you enter them in, you type something in probably in some kind of plain English or a combination of words and numbers or special characters. But once you type them in, the operating system has calculations that it performs on that password, and it stores it in a hashed value. What is a hashed value? Well, it takes that password, sends it through a one-way hash. This means it's a mathematical calculation that once you pass it through, it spits out at the end of it just a hashed value, which is a bunch of gobbledygook. It just represents that password, but it's not really that password. Likewise, even if you had the original mathematical algorithm that was used to calculate that hash, you couldn't just take that hash, send it back up through the algorithm, and have it translate back to you the original password, because it's only one way. It's not symmetric. It's what we call asymmetric. Kind of an interesting way to see that, by the way, is to use a handy little calculator. So, for example, if I had this calculator called HashCalc, I could go ahead and figure that out. By the way, we can download this, as you can see from the bottom here, from slavasoft.com. It's kind of interesting to use. Now let's go ahead and take a look at an example of how we might work that out. So for example, what if the hash that was run through my computer spit out just this result hash of whatever my password was? There's no way by looking at that, what my password was. It could have been 5 characters, could have been a dozen characters, could have been alphanumeric, upper lowercase, special characters, who knows what in the world this could have been. Or it could have simply been an asterisk, I don't know. So one thing I could do, though, is to kind of make password guesses here. What if I think the password was password? Well, then I'll just run through here and I'll just calculate this. And if it's in Linux, then Linux uses an MD5 hash. So I'll take that hash, and I'll just kind of resize this so it's a little bit easier to work with. And I'll compare it with this one over here. And it doesn't look like that's quite the same hash, so we'll have to work with something else. By the way, what would happen if I just made one simple change? For example, if I were to make this an upper character P. Well, I don't know if you remember the previous hash, but they're nothing alike. Even if I just look at these last few characters, B3964, just changing one character changes it dramatically, the entire thing. So you're not able to do any kind of guessing by process of elimination in determining how the hash changes either. So what I would do is I just keep going and keep going until I could finally figure out possibly what that could possibly be. So maybe I would be, secret hash. Let's try that one. Okay. Oh, hey, look at that. Looks awfully close, doesn't it? Well, of course, it just so happens that I knew what that was going to be, so I kind of had advanced knowledge, and that's cheating just a little bit. However, you get the idea here. This is exactly what password cracking utilities do as well. They say, let's try this password, and this is the result. Does it match what the hash is in the SAM database or whatever database we're using to compare this hash up against? And if it doesn't match, then it goes to another word and tries another word. Well, you can imagine this could be computationally demanding, and you can go through thousands and thousands, hundreds of thousands of various combinations of words. And we'll take a look a little bit later on about the different methods that can be used for that. But this gives you an idea for how the hashes are calculated and how we go about trying to use things such as dictionary attacks or brute force attacks against them. And also, where are these passwords stored? Well, they're stored usually in some kind of a secure storage. And typically in older versions of Unix, they're stored in an etc password location, and in Linux, they're stored in etc password, and then there's also a shadow file that accompanies that. The shadow file has the actual hashes itself, and that's what we need to be able to compare against when we run some kind of a password cracking utility against our Linux passwords. In Windows, they're stored in the SAM, and this is especially true of older versions of Windows or in standalone machines, such as a Windows 2000 or a Windows XP machine, especially a Windows 2000 or 2003 box that is not a domain controller. That's a whole different story right there. But anything that requires local user accounts, it's going to store them in the SAM database. But that SAM is unavailable while the computer is turned on and the operating system is running because it's got a lock on that SAM database. So in order to get access to the SAM database, what we have to do then is to be able to boot it into a couple of different modes. There's a really good utility called NTFS-DOS, and you can put that on a floppy disk, for example, and boot off of that floppy, and it allows you to access an NTFS file system from a DOS boot floppy. To access this, you can go to winternals.com. This and many other outstanding utilities written by a guy named Mark Rusanovich, who's a very, very strong programmer and really does some good magic. And as long as I'm thinking of it, and it's not really part of the Certified Ethical Hacker objectives, but as long as I'm thinking of it, he also has another utility there called ERD Commander, or Emergency Recovery Commander, words to that effect. But you'll see it there if you go to that website, and that's another thing you can do. You put that on a bootable CD, then you can boot your Windows box off of that CD and change the passwords of any account you want. Typically, it's going to be the administrator account. But you can change the password of any account you want on that box. Of course, you have to have physical access for that to happen. But beyond this locked file anyway, for NT in the Windows Repair SAM location, there is a copy of the SAM database there. That's going to be put there the first time that NT is installed, and it's also refreshed every time you run the RDisk utility. That's RDISK, the RDisk utility to back up critical information about NT. One of the things it also backs up is the SAM, so it'll keep a copy there. For Windows 2000 or greater, such as 2000 XP, 2003, it creates that also that backup in the repair directory. And I created a backup earlier today on this local machine, so let me see if I've got the particular location. Okay, there's my system state. In current versions of Windows, you just create a system state backup. It doesn't have to be named this in this folder. That just happens to be where I stored the backup file. And then where I've got my actual data for my SAM backup, let's go ahead and take a look at that. And we'll identify that in the Windows, and if we move on further down here, we'll see that there is a repair directory, and then there is the SAM. And if we take a look, today happens to be March 9th. That is the date of this SAM file. Now, before I created the backup that I made earlier tonight, this was a file that was only the one that was originally installed when I first installed the computer, and it had a date of like May or something like that. Well, what does that tell you? That tells me that I could crack against a SAM file, but it might be an old SAM file, and it might no longer be current, might not have any current user accounts, or the passwords have all changed, therefore the hashes have all changed as well. So when you do some hashing, and if you're going to work with these backup versions of the SAM, just be careful that it might not actually be the current version. Now for Active Directory, all that stuff will then be stored in a file called ntds.dit. This is stored in a protected storage location. This is also a file that's locked. You can't just double-click it and crack it open or something. And in addition, Active Directory accounts, because of the Kerberos authentication that takes place during the logon, they are much more difficult to crack. Your best chance for cracking Kerberos is to not crack Kerberos. Your best chance is if your domain maintains backwards compatibility with older operating systems, such as Windows NT. If that's the case, it might still be using NT-LAN manager hashes, and those certainly are crackable, and you can even pick those off the wire using a packet sniffer when somebody logs on, and then you can crack against that hash that you saw going across the wire. But again, that depends upon kind of dumbed down versions of Windows for sake of backwards compatibility. Now, unfortunately, there's quite a lot of those kinds of machines out there because a lot of organizations, especially government organizations, I might add, are very slow to upgrade. They'll do very, very slow pilot programs when they're ready to upgrade, and it might take 2 or 3 years of study. So you've got some organizations, and this is the year 2006, some organizations that are still trying to get away from NT4, and they're migrating to, guess what? Yeah, Windows 2000, and that's with Longhorn and Vista on the horizon. So because of those backwards compatibility kinds of things, we still have a pretty broad access to old methods for cracking passwords. However, there are some tools that are showing promise for cracking things such as Kerberos. One of the key components of a Kerberos transaction is something called a pre-authenticator. And there's a utility called KerbCrack, K-E-R-B-C-R-A-C-K, KerbCrack, that has the potential to decipher that pre-authenticator and be able to decrypt it. And I have not seen myself a lot of successful cracks using that, but it does open the door and open the gates for the possibility for something more serious to happen in the near future. Well, I've talked about hashing a little bit. Let's get a little bit more specific, at least in terms of Windows, what goes on with this hashing. Once again, Linux, current versions of Linux use MD5 hashes. With Windows versions, we usually have one of these things to choose from, one or more of them to choose from. LAN is pretty much, or LAN Manager is pretty much the first version of any kind of hashing that went on with Windows. Very early versions of Windows would work with this. Now, what happens with LAN Manager, which is a very weak version of hashing, is that it would store all passwords that it saw in all uppercase characters. So even if you typed in upper lowercase, still spits it out as all uppercase. So that reduces the complexity of your passwords substantially, and also makes it much easier to guess because any password cracking utilities don't have to be concerned with upper or lower case. Well, another thing with LAN Manager passwords is that if it's a longer password, it breaks it up into two parts. So, for example, if this is a 14-character password, it breaks it up into 7 parts here, 7 parts here, and because of that, password cracking utilities can work on one half independently of the other half, and that computationally makes it much, much simpler to be able to guess the passwords. LAN also uses a digital encryption standard, or a DES key, which is only a 56-bit key, and it uses the same key for both sides of this encryption. Now, NT-LAN Manager, which was available, of course, with NT, was a replacement for LAN Manager. Now, it used an MD4 hash, but that had a computational weakness in it, and so it wasn't the best either. Since then, it's been replaced by an MD5 hash instead, which works much better. At least it's better than old LAN Manager. Now, one thing we also have with NT-LAN Manager is that our hashes are now stored instead of in two 8-bit blocks like we had here in the hash method for LAN Manager. Now it's stored in one contiguous 16-byte block, regardless of the length of the password. This makes it substantially more difficult in terms of computational difficulty to be able to crack it, because now with 16-byte block here instead of 2 7s, then it makes it very, very difficult. And by the way, I mentioned 7s here, but then I also mentioned 8 bytes. Yeah, you can have 7 characters here, 7 characters here for a total of 14 characters, but each one of these blocks is 8 bytes long. Okay, you don't need to memorize that for any particular reason. I'm just trying to be accurate in what I'm describing to you there. Well, whereas here, this is one block of 16 bytes, and it's much more difficult for password cracking utilities to work with. Now, the drawback to using NT-LAN Manager, among other things, is that backwards compatibility issue. Yeah, we got NT boxes on our machines, but we also have some older Windows machines that still need LAN managers. So what do? We still leave open LAN manager possibilities, and when that happens, a password will be stored in both the old LAN manager form as well as the NT LAN manager form in the SAM. And then what we do is we use our password cracking utility to go after it in LAN man. That way we can use this easier computational method. We can convert everything all to uppercase. And then all we have to do is, once we guess this password, is just to manipulate the cases upper and lower. There's only so many combinations it could possibly be. So it doesn't take that much longer to come up with the NT LAN manager password either. Now, when we go to NT LAN Manager version 2, this is a very good security method. This is going to use a 128-bit key, so it makes cracking computationally extremely difficult. But once again, the loophole in all of this is that backwards compatibility again. You might be in an organization where they started off with old Windows 95, 98 machines and then a few NT machines. So we had both LAN Manager and NT LAN Manager. Then we upgraded all our domain controllers to Windows Server 2003. But we still have some of our old clients on the network, so we need to keep these in mind. And so once again, we kind of dumbed down the mighty, Kerberos capabilities of Windows Server 2003 by allowing all of these older versions of hashing. And then what usually happens is, eventually we do upgrade all the clients to XP or Vista, but nobody ever thought to go back into the group policies and tighten up the security so that it would not use any of these backwards compatible methods anymore. Let's also take a look at some of the cracking methods that can be used as well. And we'll use some of this in practical demonstration shortly here, but one of the things you could do would, again, just be guessing. You might have social engineered somebody, you might have gotten to know somebody, know what their hobbies are, know what their pet dog is at home. Well, you might try doing those kinds of things, what their birthday is. So enough things that you can possibly guess it. Also, by social engineering, you might, again, impersonate someone from technical support that needs their password. Or that wouldn't really be guessing so much as totally social engineering the password. One thing that would be partially guessing, however, is shoulder surfing. As much as I've tried to do it, I don't know if I just can't see it fast enough or whatever, but some people type in their passwords pretty fast so that even if I'm looking right over their shoulder, I can only get a few characters. Sometimes I can kind of put together part of a word that it looks like it might have been, and then I can just start guessing on the rest of it. So that's one thing that you can also do. And in reality, sometimes you'll have better luck guessing than you will by using sophisticated password cracking utilities and things like that. Let's also take a look at dictionary cracks. Well, this is what our utilities are going to be using. But the first thing you usually do is you compare the password hash against the hashed value of words that appear in a dictionary. And you can get these dictionaries all over the internet. You can just download them, and they're usually just plain text files, and you point your password cracking utility at that dictionary file, goes through each word and comes out with the hash and it looks to see if it matches the hash of that user's password. If it does, then it knows it's got the correct password. There's also an issue of brute force. What if my password is not a dictionary password? I'm using good passwords, upper numeric, upper lowercase, alphanumeric, special characters, all those kinds of things. Well, you're not going to be in the dictionary, so you'll have to do a brute force. And that's just where it will start to go through a whole sequence of, let's try A. No, let's try A1. No, let's try B5. No, let's try B5 ampersand. And it'll go through all kinds of things, which computationally speaking, you can imagine, is quite intensive. Brute force attacks have some limited success, but you might never, ever break it using a brute force attack. It just could be, that complex of a password. And then you might also have a hybrid attack. This would be where maybe, the person has what starts off as a dictionary password. Maybe their password is maybe like nature or something. So their password is forest. But the administrator came down and they said, hey, wait a minute, you can't just have letters. You got to have numbers in there somewhere. Oh, all right, fine. You guys are always griping and complaining about security. Nobody cares about that. Well, I'll just put, I don't know, my age on there. So I'll put on, 52. Not that I'm 52, mind you, but somebody out there in the world is. So they put 52 on the end. Well, a hybrid says, we'll start with a dictionary attack, and then we'll brute force the rest. So we'll say, how about forest, 01? Oh, that didn't work. How about forest 02? Oh, that didn't work. How about forest 03? And then so on and so forth till they finally get to forest 52, and the hash comes out the same as the hash in their stored values for that client's password, and finally we get a result that matches. Yahtzee, we now figured out what that user's password is, forest52. And a lot of those people that have passwords that are very difficult to crack have just simply chosen good passwords. This is really something that has to come down from IT management. On Windows Active Directory boxes, you can configure the password policy in group policy, and you can specify how long the password is, when it expires, whether it needs to use special characters. All those kinds of things can be easily configured in that for the domain policy. So what we'll do with this also is to configure a lockout policy. Now, by default, Windows domains do not have a lockout policy. So you could try to do a brute force attack by hand and try to continually guess somebody's password indefinitely and never be locked out. However, if you enable a lockout policy in the domain, then typically it's going to be 3 attempts, okay? And if they don't successfully attempts, if I can spell correctly, if they don't successfully guess the password right after 3 attempts, it locks that account. And there's a lockout duration for like 30 minutes is usually a good one that's used. So that substantially slows down any brute force attacks. Another reason why it's good to have a lockout policy is because this will record itself in the event log. And if you have event log management software that will page you if there's an unusual sequence of events, then what you might see is, you had 80 accounts that got locked out because they had too many invalid attempts against that password. Well, you know that your network has then suffered under a brute force attack and somebody's trying to hack into your network. There's also an issue of expiration. You don't want passwords to get too stale. The longer a password stays the same, the more likely someone is to hack it or to crack it. For example, with a brute force attack, it could take days or weeks, but if your password policy says to change your password only every 90 days, well, they've got 3 months to be able to crack some of those passwords. That's way too long. Another thing you can take a look at there is that you'll use at least 8 characters, and the reason for that is because remember how we had our LAN manager passwords that were stored into 2 7-character parts? Well, if we make it 8+ characters, then we computationally increase the amount of work that a password cracker has to do. Because then it has to try to guess on both sides of that password, and it'll have to guess both 8-byte parts of it. Now also try to remember to use alphanumeric, upper lowercase, and special characters in your password requirements. Now, of course, upper lowercase won't make that much difference if you still have backwards compatibility for LAN Manager. But once you've eliminated that, upper lowercase will make it more difficult for password cracking utilities to crack the passwords. Also, for special characters, ampersands, exclamation points, pounds, caret, percent, asterisk, any of those kinds of things could also work and make it much more difficult for password cracking utilities. Let me also give you another tip here, by the way, and I'll just kind of reduce everything, and let me just create a new text document to show you this. One thing I do that makes passwords virtually impossible to crack is to use ASCII characters. Well, where do we get those? If you hold down Alt and you type in sequence numbers on your keypad for your numbers, and you have your numlock key turned in, you'll get some strange characters. So, for example, if I start every password with, or have somewhere in the password, hold down Alt 0141. Well, that gives me whatever that is. I think that's actually an equivalent of a space. Well, that's not going to appear in any dictionary in any language because of the strange character that is. So that might be a good way to also lock your passwords down. Now then, there's some schools of thought, and a lot of this is actually coming from out of Microsoft. I've heard some guys at Microsoft talking about this, as well as a guy named Mark Manasseh, who is very strong in Windows topics. They seem to start liking passphrases. Passphrases. These would be more like a sentence, like, I like to dance in the rain, something like that, which is going to be a much longer kind of a password than a normal password where you have 8 characters, 12, 14 characters, something like that. The advantage of a passphrase is it's easy to remember, but difficult to guess on behalf of a cracker or a hacker. So much so that it's nearly impossible to crack as long as you're the least bit creative with whatever passphrase you decide to choose. You don't have to use any complexity with it. Of course, it helps it even more if you do, but because it's so long, you can just use plain letters with, all lowercase if you want, all uppercase. It doesn't really almost even matter because of the real length of a passphrase makes it very difficult to crack. In some environments, in fact, when they're using passphrases where they've caught on, they don't even use a lockout policy anymore because, 3 attempts, that's something, but you'd have to have millions of attempts, if not billions of attempts, to try to guess some of these passwords if they're using passphrases. Now, another thing to keep in mind, be realistic about password cracking. First of all, password cracking, especially for good passwords, is going to require time. That's my little clock. I hope you like it. I'll make this a wristwatch instead. How about that? So anyway, that does require a bit of time, and you might be sitting there for hours, days, weeks, or you might sit there indefinitely trying to crack these passwords. Well, if your penetration test only gives you a week to be able to crack all of this, and your password cracker's already worked 5 days with no result, you're wasting your time, so you might as well move on to some other things. You know, go back to social engineering. Remember, there's always somebody who will fall for a good con job. Go to those new employees that haven't really been, dipped in the wool, so to speak, or dyed in the wool with the company, and they don't know all the policies quite as well and all that kind of thing. Well, maybe they'll give up a password. Also, a lot of times the passwords are really in plain sight. Don't forget, some people stick, Post-it notes on their monitors. They're not supposed to, but inevitably you'll find that somewhere. In fact, I recently went to an office where I didn't even intend to do this, but I was having a problem with the keyboard. There was a stuck key or something, and so I turned it over because I was going to go ahead and just unscrew it and see if there was something down in the keyboard. Well, underneath that keyboard, you know how the little feet on the keyboard flip up? I flipped up one of those feet, and stuffed in there was a small, almost origami kind of a folded piece of paper with that user's password on it. So, lucky day for me on that one. Unfortunately, I wasn't on a pen test, but it was still interesting to find a password. Also, what we have here are scripts. A lot of administrators will create scripts or certain kind of like cron jobs in Linux. They'll create these things, and they have to put the password into the script in order for it to be able to run without a user being physically logged onto that computer. So if you can find those scripts, if you can find a directory somewhere that identifies those scripts that a lot of computers are accessing over the network or something, pretty good chance you might be able to find a password in there. So again, much faster than, watching the clock tick by in your pen test. Also, don't forget you can sniff traffic as well. Now, you can sniff those plain text passwords out. Now again, Telnet's getting more and more difficult. There's SSH encryption that's going on with a lot of that now. Much more difficult to crack. But certainly there's enough free stuff going on out there where users are downloading files from FTP sites, and they're using, maybe it's just a personal download. They're downloading a game or something like that. But a lot of times the users will use the same username to download something like that on the public internet that they do for their own company because it's easier to remember only one password. And finally, remember, a lot of this is going to really require physical access. And that's why, even though when, utilities like Loftcrack came out, which we'll look at shortly here, when they came out, initially everybody just, ooh and ah, and oh wow, there's no security in Microsoft products. But guess what? You have to have physical access to be able to use Loftcrack in many cases for its most effective purposes. Well, if you've got physical access, then you've already lost that machine, and there's really not much security there anyway. Also, a lot of these, in order to get access to the hashes and things, you have to be an administrator. Well, if you're already an administrator, what's the point in cracking any of the passwords? Just create your own account if you want another account to log on with, and set your own password. So, a lot of it is a little bit of a circular argument with this. All right, well, let's go ahead and get started hacking. This is where the fun begins, and we'll get started on a Linux box hacking against the shadow file. What I'm going to do here is go to a console, and here I'm just going to use a utility called John the Ripper. This was written by a hacker, a masterful guy named Solar Designer. And wow, isn't that just the coolest hacker alias you ever heard of? Solar Designer. Anyway, I'm going to go to user local. I'm not typing too well tonight. It's getting late. Okay, John. And then we'll go to the run directory. And then you'll see that the John executable is in this directory. Now what I want to do, first of all, let's just test it to see how it runs. John, and then -test. And this will just give us an idea of how fast John is going to be capable of cracking passwords. Just creates a benchmark of how it works against various kinds of hashes. For example, against standard digital encryption standards, which is a 56-bit key, how many salts, how many characters per second it can work against, and so forth. So we'll get an idea for how it can work there. And then the other thing we'll be doing is to go ahead and go to our John file, or rather our shadow file. All right, so it's now done, figuring out how fast it can work through all of those things, just benchmarking all of the various kinds of hashing algorithms that it can work with. Next thing I'll do here, let me just clear the screen to make it a little cleaner. We'll change directory. Oh, we're already in that directory. So we'll copy our shadow file, etc shadow, and we're going to copy that, and that's going to go into our local directory. So again, ls shows me that. We now have the shadow file here. Next thing we'll do is I'm just going to go ahead and run it. So I'm just going to do ./John shadow, and it's going to run John the Ripper against this copied shadow file that I've copied to this local directory. So go ahead and press enter. We'll go ahead and let it get started. Now, see quickly, it already guessed one of these passwords, Bucky. That's the name of the user, and that's their password. Big duh. That was probably pretty easy to figure out. So this person did not choose a very smart password, obviously. Okay, let's see what else we got. Oh, you might be looking at this and saying, James, what did you do, man? You just got a utility that just hangs and doesn't seem to really want to do anything. Well, it certainly looks like that, but actually this is very smart what's going on here. You see, Solar Designer created this in such a way that it doesn't use any additional CPU cycles to show us some fancy graphics or a GUI or, any text scrolling up and down the screen in Matrix style, any of that kind of stuff. But if you want to confirm that it's actually working, you can press the space bar, or no, actually, the space bar, or you can press the Enter key, either one, and that will show you what word it's currently working on in its sequence of guesses. By the way, this does take a while to crack some of these passwords. I entered in some complex passwords that John may never get, but if any cracking utility can get it, it probably will be John. Or it could also be Cain, as in Cain and Abel, and I'll show you that utility a little bit later on here also. So in any case, I'll let that go ahead and do its thing. Maybe we'll come back to that a little bit later and see what else it's able to crack. All right, let's go ahead and take a look also at our Windows XP box. Let's see what we can kind of crack over here. A couple of different things that we could do. One of those things is to use an old utility that's kind of an oldie but a goodie, but it's being retired, and that's a utility called LoftCrack. Now, LoftCrack, I just downloaded the trial version here. LoftCrack is actually not available anymore because At Stake, which is the company that originated this utility, which is the same group that Solar Designer worked with, well, guess what? They got bought by Symantec. Guess what Symantec does? Well, they do security. So you don't think that they would want to have LoftCrack, a password cracking utility, under the umbrella of Symantec. And they just recently, I think it was just this week, in fact, announced that they would no longer offer LoftCrack at all. Kind of sad, because this is a classic password cracking utility. But anyway, what you do with this one is you just, kind of next to you finish your way through it. It's very easy to use, which is another one of the advantages from it. What I can do is I can retrieve by sniffing on the network. This has some limited capabilities because it doesn't always work with all network cards, including mine right now, so it doesn't always work with that. There's also an NT4 emergency repair disk. Remember, it backs up the SAM. Well, if you have the NT4 emergency repair disk, you can use that. You can work with the remote machine, provided you have the administrator access to that machine, or you can retrieve from the local machine here as well, which again means that it's going to pull it out of the local database. So what we'll do here then is we're going to go ahead and do a quick password audit. So we'll go ahead and do that part of it, and then I'm just going to accept the default values. You can look at this yourself. And now you kind of have to search for Google for this utility because you can't download it from just anywhere anymore. But do a Google for this utility. You can still get it in certain places where people have stuffed it away on FTP sites and stuff. And then just choose the default methods here, and we'll click on Finish. And we'll just let it start guessing at passwords. And for example, we see that we did get some correct password guesses here, and we just did a dictionary attack on this first attempt. So Melissa's password was, guess what? Missy. So this user's name was Missy. A very easy way to guess this. Now remember, the LAN manager password converts to all uppercase. The NT-LAN manager password is case sensitive, however. Sam, this person, his password was vulnerable. And, again, an easy dictionary password to work with there. If I wanted to make it a little bit more difficult, what I could do is go to the session, go to my session options, and then I could choose, instead of using a dictionary crack, I could choose a couple options. I could go to a different dictionary, and I could add an additional dictionary into this, and then I'd browse for, dictionary words that I'd downloaded. So, for example, there's a really big dictionary file. By the way, I want to just take a look at it. Like I said before, it's really just a text file, and this can probably take a little while to open because it's a really big file. But you can see that it just starts off with a whole bunch of numbers, then it goes into a bunch of letters, then it goes into actual words, and this just goes, man, I don't really know how big this thing is, but it's a pretty huge file. So you just add any dictionaries that you want there, including foreign languages, that kind of thing. Or you can do a brute force attack, and this is probably what I would do if my dictionary aren't working very well. I'll do a dictionary / brute force. so it takes advantage of the best of both worlds. And if that's not working either, then I'll fail over to a brute force crack alone, but that could take forever, or I might never get it cracked. But at least you get an idea for how this utility works. Oh, you know what? Something else occurred to me. What I should tell you also, let me just open up this file here and spell it out for you. Loft crack, if you do a Google search for it, is L0PHTCRACK. Okay, so it's not an O, that's a 0. Just keep that in mind so you know how to spell it if you search for it. All right, other things we can do here are to use something called PW dump. Now, why would I need to use PW dump? Well, remember, even with current versions of Windows, the SAM is going to be locked up. It's going to be in use. You can't just copy it somewhere or anything like that. You can always go back to your old backup, but again, that might be months or years old, and it might not be current at all. So if possible, I'm going to use the current one instead. And what we'll do with this is kind of jump ahead of ourselves a little bit, talking about Windows exploits. You see, there's a utility called PW dump 2, and it uses a technique that's known as DLL injection. What happens is it forces another process, in this case it's going to be the local security authority, or LSASS.exe. It's going to force it to load a DLL, which is going to be samdump.dll. Anyway, I know that's a lot of talking about injection and all that. Basically, the short version of this is it loads a program kind of stomping on another program, and it causes it to shoot out the middle, kind of like squeezing a tube of toothpaste. It causes it to squeeze out a bunch of password hashes that we can then take advantage of. And I just realized I'm on the wrong computer. So let me go over to my server here where I've got the utility for pwdump that we'll work with here. So what I'm going to do here is change directories to pwdump. And then running the utility is just really easy. Just type pwdump2, that's the name of the utility, followed by, I'm going to pipe this out to, like a passwords file. So passwords.txt. And then if I do a dir again here, then we see that it did dump it out to passwords.txt. So what I'll do now is go to Windows Explorer, crack that file open, and then I'm going to try to exploit it on my other machine here real quick here. So let's find my passwords.txt file. And what I want to do is I'm just going to select all. I'm going to edit, select all. Then I'm going to go to edit, copy, close this out. And then I'm going to go in here to my Windows XP box, where I've got another file here called passwords. Now I'm going to paste all of that in, because between virtual machines, copy and paste will be able to work here. So you can see what we've got going on here. I've got the name of the user, administrator in this case, followed by their SID, the ending part of their SID. Remember, administrator always ends in 500. This is also an easy way to identify, again, who the administrator is in case that account has been renamed. And then I see their hashed value for their passwords. Okay. Now remember, what we got here, take a look at this. We see colons separating these mostly about halfway down. Why is that? Because remember, these are going to be LAN manager equivalent passwords that are split into two parts. Also, there's a little clue here so you can identify any passwords that are 7 characters or less. Anything that ends in double E right before that colon there, actually it's this last few numbers here. You can see how some of them have that in common. Well, that's just a visual indicator that these have short passwords. So that might be another thing to go after. If you're just looking for any password, you just need to get some access to the system, try to find the ones that look like they have the easiest passwords for you. All right, I'm going to go ahead and save that as I close it. All right, so before I move on, let's quickly review what I did. I went over to this server here, and I used pwdump to dump out a list of passwords, and it dumped them out into a text format that I then selected it all, copied it into this passwords.txt file, and then I'm going to use that. You see, this passwords.txt file by itself doesn't really do anything for me until I run some kind of a cracking utility against it. All right, so what I'm going to do is to run a utility called Kane, and I've showed you this before, I think, but you must download it from oxid.it. It is just the bomb for decrypting stuff, and it does so much different stuff. It's a network sniffer. It can decrypt things on the fly. It cracks passwords. You see all the different kinds of algorithms that it can work with here. It can even work with Kerberos 5 pre-authenticated hashes, which again is kind of an emerging hack. Base 64 encryption, which is what's used for basic encryption for web access for different kinds of things. So, VPN access, Cisco cracks, all different kinds of things can be run against this. Wireless cracks, RAS, all sorts of things. So this is just an outstanding utility, free, and you really must get it. Okay, so let's get to work with this. The first thing we're going to be able to do here now, once I've got this thing open, is I'm going to right-click in this empty space here anywhere, and I'm just going to right-click and choose, how about a add to list? That's what I'm actually going to do, add to list, because I got to find my file. So I'm going to import the hashes from a text file that I put on the desktop just a moment ago that was called passwords.txt. That's the file I just showed you. So I click that. Now I'm going to work with that when I click on next, and it brings in the names of all of these people. So what I'll do is I'll just select the first account here, and then I'll shift-click the last one. Next thing I'll do then is to right-click, and I'll just choose a dictionary attack, if I want to use a dictionary, or let's just go to brute force attack this time. I'm just going to do LAN manager hashes, and it brings up this dialog box for me. I'm just going to click on start, and notice that it just goes through all different kinds of iterations for different potential passwords that it could be. And if we look in the background here, or actually if we stop it, it'll show us what it was able to come up with. I'm just going to go ahead and let that run for a while, and I'll go offline for a bit, and when it's done a few minutes worth of cracking here, I'll come back and we'll see what we got. While that's running, and I'll go back to the screen so you can see that it's still running here, but while this is running, let me also point out that you saw maybe another option there as well. You saw that you could use a dictionary attack, a brute force attack. There's also a hybrid attack, which, remember, is a combination of dictionary and brute force. And then there's also an option there that was called a rainbow attack. What is that? Well, a big part of the difficulty in cracking these passwords is running it through the mathematical algorithm to generate the hashed result for these password guesses that it's doing. It's extremely expensive in terms of CPU cycle. In fact, you wouldn't know this, but I've had difficulty recording this video while these hacks are going on because it's sucking the CPU utilization out of my microphone software. So it's giving me a little bit of a hard time. But in any case, it's computationally difficult. Well, a rainbow table is something that you can get, and you can download some of them from the internet, where all the hashes have been pre-computed and put into a file. Then what you can use is just the pre-computed hashes that have already been generated computationally, and you don't have to depend upon the computer here locally to do that math. And it's much easier. It's also much, much faster. Some of these rainbow tables you can buy cost thousands of dollars, and there's some that are over a terabyte in size. But they're almost guaranteed to be able to crack virtually anything you can throw at them. So they're extremely good, although expensive. All right, well, I got a little impatient, so I decided to go ahead and stop this thing from running. So I clicked on stop, and it says it had 9 of 20 hashes cracked. I'll click on exit here, and we'll see what passwords it was able to come up with. Big admin Bob, his password is, guess what, Bob? Yep, sometimes users use the same password as their name. How about this user? User 1 is their password. Same issues there. User 5, admin. Okay, that's another password that's pretty common. What about these other ones? Well, you see that it started to work on a couple of these. It didn't quite get the whole thing done, but it got started anyway. If I'm trying to remember this Nancy one, I think I set that password as vulnerable, and you can see that I got part of it done there. And I also used some special characters in this one, which I'm surprised it even got this far because I used an ampersand, an asterisk, and something else. I can't remember what the other one was. But that made it pretty difficult to crack, and so at least it got part of the way there. And I let it run probably for 10 minutes. In this nugget, we discussed password cracking. I started off with just kind of an overview of what password cracking really is, or what passwords are in a Windows and Linux environment, that they're just really hashes that are stored in secured locations. And there's a few different methods for hashing those passwords, some more secure than others. For example, NT-LAN Manager, not very secure at all. NT-LAN Manager, better. NT-LAN Manager version 2, pretty good. And then Kerberos is probably the best of them all. We also took a look at some cracking methods that could be used, brute force, dictionary, hybrids, things like that, as well as how to choose good passwords. Because after all, even for your own personal computer, you want to use a password that a hacker would not easily be able to guess or crack within a reasonable amount of time. And then you need to be realistic. Sometimes password cracking, especially against difficult passwords, takes longer than it's really worth. You'll be better off choosing other security avenues to try to breach security. And then I showed you a few different demos. We used John the Ripper. That's probably the best one, although I used it on Linux. What I'll often do is I'll export Windows hashes, bring them into Linux, and then use John the Ripper against those Windows hashed passwords because it's really one of the fastest ones out there. And then we also used Loft Crack. Sadly, it's going away. The Loft Crack, and then Cain and Abel. Well, I hope this has been informative for you, and I'd like to thank you for viewing.